Hello students, welcome back. Today we will talk about the properties of arithmetic sequences. Before we introduce some additional properties, let's do two more examples to familiar with the questions in arithmetic sequence. So now consider the arithmetic sequence here. How many terms are there in the sequence? Okay, first of all, may we just remember the formula. Tn general term equals to a plus n minus 1d in the arithmetic sequence. So now, how many terms are there in the sequence? Actually, it means we are going to find the n. So let's see whether we can find the Tn, a, and d. First of all, we can find that a is negative 25, which is the first term. And then we try to find the d, which is negative 22 minus negative 25. And then we get 3. And now, if we want to know the terms, then we look at the last term. So the question is, which term is it? Then we try to let it is the kth term. So we let k, first of all, be the number of terms. In the sequence. So now if there are k terms, so this one will be tk, right? Then we get tk is 26. And then we'll use the formula a plus n minus 1. So now it's k minus 1d equals to 26. And then we get 3k minus 1. So it will be 51. So k minus 1 is 17. So k is 18. And then, okay, lastly, we give the statement. So there are 18 terms in the sequence. Okay. And now we go to part B. Okay, determine whether 3 is a term. Then again, we use the same skill. We just try to find, okay, suppose there's a term Tm which is equal to 3, and then we see whether we can find the value of m. So again, a plus n minus 1d, so now it's n minus 1d, and then will be 3. So let's do the similar step. So we get 28. So m minus 1 is 28 over 3. M is 31 over 3. So obviously, m is not a positive integer here. Okay, because m is the term. Okay, it's like t1, t2, t3. You won't have like t1.2 or t2.5 like that. So because it is not a positive integer, so there's no such a term of 3. So 3 is not a term of the sequence. Okay, get it? So we go to the next one. This is a little bit similar to example 1.6, but the questions, okay, we need some more skills, okay, even in the inequalities. So now consider the arithmetic sequence. We have a sequence again. Now, how many positive terms are there in the sequence? Then first of all, when you look at the sequence, you find that it is decreasing, right? You get 82, and then you get 76, 70, 64, and then you can decrease the numbers, right? So there must be a time that the term will become a positive number, will come from a positive number to a negative number, right? So we are going to find that. So the question for A actually is, which term, now is this decreasing, right? Which term is still be positive. Okay, we're trying to look at this one. So now, first of all, we let again tk be the last positive term. Because it is decreasing, right? We must have the last positive term, and then after that it will become negative. And then we find A is 82, D is -6, and then we have, now if we want tk be the last positive term, that means tk must be positive, so we set tk greater than 0. Okay, so now we get a plus n minus 1d will be greater than 0. We just expand in these questions. 6k. Okay, then we get 88 greater than 6k, so k will be smaller than 88 over 6. So actually we use decimal in this situation will be easier. Okay, so 14.7. So k is smaller than 14.7, and k is a positive integer. So what is k? The biggest one is 14, right? So there are 14 positive terms in the sequence. Okay, so now we go to part B. So now we have 14 terms of positive, and then which is the first negative term? I'll give you 5 seconds to think about that. Okay, in this sequence, the first 14 terms are positive, right? So the negative one will be the 15th one. Okay, the 15th. So by A, the first negative term will be T15. So we get A plus n minus 1d. So finally we get this is -2. Okay, so we found this term as well. So here we come to 2 more properties of arithmetic sequence. If you ask me, these 2 are not necessary to remember it, okay, hardly. Okay, but this is like some applications of the concept of the arithmetic sequence. Now let's look at the first one. If we have 3 terms, and these 3 are 3 consecutive terms of an arithmetic sequence, then Tn equal to this one. Okay, the sum of the first one and the third one, and then over 2. So here basically you just make use of the common difference, the concept. Okay, because you get Tn plus 1 minus the previous term, then what is this? Will be d, right? Okay, and then you also have Tn minus the previous term, which is Tn minus 1, and this is also d. Then these 2 are both equals to d, so we get they are equal, right? This should be -1. And then we just move the terms. We will have this one. Okay, so finally we will get Tn plus 1, Tn minus 1 over 2, which is Tn. So this is the same as this one. So in arithmetic sequence, the middle term will be equal to the previous term and the next term, okay, the sum of them, and then over 2. But okay, for me actually, if you know this or this one, then it's already enough, okay, for you to do this out, and you don't need to remember one more formula. Okay, let's go to the next property. So if now this 3 okay is an arithmetic sequence with common difference d, okay, then this one is also an arithmetic sequence with common difference kd. Okay, let me show you. So if T1, T2, T3 is an arithmetic sequence with common difference, so we just, in general, Tn plus 1 minus Tn will be d, okay, for any positive integers n, right? So we first get this, and then now for any positive integers n, we try to look at what is the value of this ktn plus 1 minus plus c minus ktn. It means that generally the term minus the previous term in the new sequence. So we expand it and simplify it. Then you get this one. And then you will get kd as well, right? So we prove it. Okay, because n can be any positive number, so any terms minus the previous term in the new sequence will get you the common difference kd. Okay, so okay, we get the proof of these two properties, and now we just do the last example by simply using this, okay, one of the property. Now we have 3 terms and they form an arithmetic sequence. Okay, bear in mind, look at the questions carefully, and then we find the value of a. Okay, so here we just have 2. Okay, I just simply show you 2 methods. If you don't use the property, then you simply use the third term minus the second term will be equal to the second term minus the first term, right? They are both equals to the common difference. So we get 2a minus 2 equals to 2a minus a plus 2. So 2a minus 2, a plus 2. So finally we get a is 4, right? Okay, and if we use the property, we just learned that the middle one will be equal to the first term plus the second term plus the last term over 2. Okay, and then 2, let's multiply the 2 here. So we get 4a equals to 5a minus 4. So we get negative a equals to negative 4. So we get the same result, right? So you just use the one. Okay, in actually many sessions or chapters, you find there are some skills which you can choose to use. So choose the one you are familiar with. Okay, there's no perfect skills or perfect formula. So the one suit you, okay, is the perfect one for you. Okay, so we will start chapter 1.3 next week, next lesson. Okay, so see you.